Hi guys. Okay, we're live. Awesome. Thank you so much for the amazing introduction. Yeah, thank you all for coming here to hear me talk about building UI machines with Zag.js. I know it does sound weird, but believe me, it is super interesting. So my name is Lazar Nikolov. I am a developer, designer, content creator. During the day, I am a software engineer at Skopje. It is a local software outsource company here in Skopje. During the night, I am a maintainer at Chakra UI. Does anyone know here what Chakra UI is? There we go. Nice, cool. All right, very nice. All right, so yeah, I am in the React core team of Chakra UI, and I'm also an instructor at DevCon because I like to teach people things. My Twitter handle is Nikolov Lazar. I'm a friendly dude, so if anyone wants to hang out and talk, you can find me there. And I also try to keep my website always updated, so you can find me at nikolovlazar.com. Okay, so for those of you who don't know what Chakra UI is, it's a component library that gives you the building blocks to build your website or web app, etc. But it's actually a design system implementation. So if we, for example, want to compare Chakra UI with Material UI, let's say, I would say Material UI is it has more components and stuff, so you can build straight with it in production. And Chakra UI does have not that many components, a bit lower number, but it's actually, the design system implementation is actually the key feature that Chakra has, because it's 100% extensible, and people actually use it to build their own design system on top of Chakra UI, and no one knows that it's built with Chakra UI. So that's Chakra UI. We are proud to say that we have 1 million monthly downloads, which is amazing. It was surreal. I woke up one day, I checked the NPM stats, I saw 1 million, I was like, okay, this is the next level. And yeah, we also have the Git Nation React Award for the most impactful project to the community. So that is Chakra UI. Let me tell you a story. I mentioned I am in the React core team of Chakra UI. We also have the Vue.js. That's another set of people who are working on the Vue.js version of Chakra UI. And since February last year, when I joined the core team, we've seen a fair share of bugs and issues related to how we coordinate the JavaScript events, how we manage the state inside of the components and side effects, the standard open source thing. But then upon talking with some of the Vue.js core members, we actually realized they have the same bugs as us because we copy-paste each other's codes. Right? We need to ship fast. They did a thing, copy-paste it into React, optimize it for React. We did a thing, copy-paste it into Vue.js, optimize it for Vue.js. So for every bug, we also need to fix it twice. And as we developers know, and our favorite phrase is, that doesn't scale, right? So yeah, that created a maintenance hell for us. And we need to take a step back. We believe that the most web widgets should function the same, regardless of they're built with React or Vue, or JavaScript or TypeScript, or any of the other frameworks. A slider is a slider. The user doesn't care about the framework that they've built, they just want to use it. So that's when we took a step back and started to think about a solution that will take care of that. And now I'm going to introduce Zag.js, our new library under the umbrella of Chakra UI. And Zag.js is actually a framework agnostic toolkit for implementing complex, interactive, and accessible UI components. We are big on accessibility. We try to put accessibility into everything. It is built on top of the latest ideas in state charts, and I'll tell you why later. It is basically a collection of state machines that describe the logic of every web component that we can find on any website, right? So the machine APIs are completely unstyled. It's just pure behavioral logic. They give you full control to use any styling solution you prefer. You can use Chakra, you can use Material, you can use Tailwind. Please use Chakra. And also we package them into their own NPM separate packages. So if, for example, you want to refactor using Zag.js, you can do that gradually, package by package. All right, so I mentioned state charts, and that means that every component is built on top of a state machine, right? So what are state machines? State machines, by definition, is a tool for modeling stateful reactive systems. It must have a finite number of states and transitions between those states. It needs to have defined states, events, actions, and a context to keep the values. And the key part right here is that they declaratively describe the behavior of an application or component. That is the reason why we picked state machines. Because if we rewind just a bit, we had the React framework, we had the Vue.js framework. We copy-pasted each other's codes. That means we are building things imperatively instead of declaratively. And if we need a refresher, imperative way of programming is how an operation should happen, while the declarative is what the outcome is, regardless of how the operation happens. So that is why we picked state machines, because we can declaratively describe the behavior of the application without using any frameworks. It's in plain vanilla JavaScript, so we can use it in any of the frameworks. But the logic is that the behavioral logic doesn't need to be bound with the framework. So that's why we used state machines to build Zag.js. Now, for those of you who don't know what state machines is, I actually brought something with me today to help you understand that. So this is, I believe we all know what this is, especially in the past 2 years, right? This is the ordinary disinfectant alcohol bottle. And I'm sorry it's way too big because this is what they only had in the gas station down the road. So I'll try to work with it. Let's try to describe this bottle as a state machine. So right now it's in the closed state. We have the cap on. If I remove the cap, we are in the open state. If I press the pump at the top, we are in the pressed state, right? So those are the states. There's no other functionalities into this everyday object. Even though it's not a programmatic thing, it still can be described as a state machine. There's also conditional states, right? For example, if I am in the pressed state, I cannot go back to the closed state, or at least someone if has a more creative solution, but I certainly can't. So that was easy. That is a state machine. But because we're all engineers and all of you came on a DevCon, which is a software engineering conference, not pharmaceutical, I also have prepared an actual UI machine, and we are going to go through the slider machine. So what is the slider? We all know what the slider is. It allows us to pick any value from the given range, 0 to 100, 20 to 40, whatever. So let's think about all of the states that a slider can. If we look at the slider like so, it does nothing, right? It doesn't change the value. It's not reacting to our breathing or talking. It just stays there. So we can say that the state is in the idle, in the idle state. So we can draw a square right here and call it idle. Okay, what if I hit tab and the browser focuses on it? So a little blue border will get drawn across the thumb there. That means that we are in the focused state. And why do we need to handle that separately? Because right now, if we press on the keyboard, left and right, we can actually change the values. So we have some additional functionalities that we didn't have when we were in the idle. So we'll treat that as a different state and also transition the arrow left and arrow right back into it. Transitions between states. When we are in the idle and we hit tab, the browser will send the focus event. And the state machine will transition into the focused state. When we hit the left and right arrows, then we transition back to the focus state, but then something happens. There's a decrement and increment actions that are happening, just as the alcohol came out from the bottle when when I pressed on the pump, right? Those are called actions, or which are basically JavaScript functions that do something. And same, for example, goes for the pointer down event. When we click on the actual thumb and hold the mouse there, we move on into the dragging state. And when we try to move the mouse left and right, we're actually transitioning back into the dragging state, but we're also executing the set value action that changes the value of the slider. And that's how the users know that the slider works. They can see the change on their screen, right? So all of these actions have access to the contexts, which is this diamond shaped here. And you can think about that as the Redux store. All of the components have access to the store, and they can dip in, they can grab the values, they can change the values, etc. So the actions are changing the context. And we're listening on the value, on the value, and we are presenting that on the screen. So that's how the whole cycle works. And for example, from the dragging state, we can release the mouse, we can go back to the focus state, and if we click someplace else outside of this slider, we'll go back to the idle state. And that is the whole life cycle of the slider machine. So now you might be thinking, okay, why do I need to use Zag.js? There are a lot of frameworks that give me sliders. Well, okay, I thought of an example. First, we built Zag.js because we had a problem, and it fixed our problem. But then we thought, okay, Zag.js can also be used to build your own design system, right? Because the behavior is already done. We have already coded all of the states and the transitions and everything. You just need to provide your own styling. So that would be a smarter way to build design systems. And let's say, for example, you have you work on a project, and the client comes to you and says, I need a slider. And you find an NPM package out there, you install it, and you present it to the client. You'll say, okay, here's the slider. Awesome, thank you very much. Then the client comes back the next morning, and he says, yeah, I also need it to be vertical, because I want to make an equalizer using that very same slider. You'll be like, okay, I'll try. So you play around with everything. You rotate it 90 degrees. You need to change the event. So instead of left and right, you go up and down now. And instead of the X value on the pointer move, you need to listen to the Y value on the pointer move. But you get through the day. And you build the vertical slider. And you present it to the client. The client is happy. They give you a raise. And you think, okay, I barely survived that because I didn't expect that. And then the next morning, the client comes back, and he says, okay, I have some clients that speak in a language which is right to left. So I'm going to need the slider to be actually right to left optimized. So instead of 0 to 100, it needs to be 100 to 0. So instead of arrow left to decrement the value, you need to increment. So you go through all of that pain while you could just use Zag.js and get yourself the solution already done. So yeah, that's a funny thing about Zag.js. Let's see how we can use it. As I mentioned, Zag.js is consisted of multiple packages for every UI machine. So we're going to set the slider aside, let it cool down. We're going to use the toggle machine now. So first you need to install the toggle UI machine. If you prefer Yarn add Zag.js/toggle. Then you need to install the framework adapter. We still need a framework adapter in order everything to hook up and be part of the framework. So for example, in React, you just need to install the Zag.js React adapter, and then you need to patch everything together. So let's see. We have the use machine and the use setup from the adapter, and we import the toggle machine, but it's everything actually, from the Zag.js toggle. Inside of our component, we can use the use machine hook and pass the machine, and then we can obtain the state and the send method. The state is the actual state of the machine that is currently in. And the send method is a method that programmatically changes the state. For example, if there's a button someplace else in the app, and when we click on it, we want the slider to reset to 0, we can use the send method to actually transition back, for example, in the idle state, etc. So there we have the state and send. Then we have the use setup hook. We pass on the send, and we have the ability to pass the ID, and that gives us the reference. So who noticed that I had an extra state that I didn't explain back in the chart? There we go. Let's go back now. Maybe you've noticed this unknown state, and I left this out on purpose, because this is a state that I created to make sense of non-existence. This is the state of the slider when the slider doesn't exist, right? We need to somehow describe it, so that's why we set it to unknown. And in order to the slider to be born, right, to show up on the screen, there are certain things that need to happen. First, the slider needs access to the DOM, so it can hook up the keyboard events, the mouse events, etc. And that's when we have the setup transition right here. And that is why this hook exists, the use setup. So we get a reference from the use setup hook, and we pass on, and we use the reference down in the, for example, in the button, because this is a toggle button. Okay? Then everything happens here in the toggle.connect. This is a method that receives the state and the send method, and it returns us the API. This is everything that you need to do if you were to do this manually. All of the click handlers, the keyboard handlers, all of the accessibility props. And let's be honest, we usually forget about accessibility props. We don't even care about them. But they're here. So we get a hold of the API. We can spread the button props onto the button itself. And as I mentioned, we will have all of the event handlers right here. We don't need to think about making these manually. But we also have access to the actual context. And for example, in the case of the toggle machine, we have the is pressed value, which will tell us if the button is pressed or not. So we can use that to apply either styling or conditional rendering based on its value. So this is a really simple example. The slider is a bit more complex because it has multiple parts and other things. But for the sake of the time, I actually didn't prepare an interactive demo so we can all see it, because I have 1.5 minutes left. That's why I deployed it on my website, nikolovlazar.com/Zag.js-demo. This will redirect you to a code sandbox link that uses the slider machine that we just saw previously, and it adds some CSS styling. So if you want to see how everything functions and change a few things and break it, feel free to go on this link right here. And of course, for more details, you can visit Zag.js.com. You can see all of the components that we have in the framework, and also what frameworks we currently support. And that's it. Thank you.
Questions? T-shirts?
Thank you. My question is, for example, if there is a scenario that isn't covered and we need it, how easy it is to customize any machine, any functionality? And that's the first question, part of the question. The second is, how do we style the components? Like how exactly, because we didn't see the code for that, so. Yeah.
Thank you. So the machines are currently not easily extendable. We are working on making them extendable, but also the idea is to make a universal solution that covers everything. Right now, we don't have the ability to add more states to the machine, because I think that's overly complicated, and we can't really count all of the use cases that could happen if we open up the machine, but it's possible to edit the context. So in the case of the toggle machine, you can add your own on-click listener. You can add your own conditionals or default values. And yeah, that is the only place that we can edit or change the machine. And for the second question, the styling, I'm not sure. Do we have the possibility to actually open the sandbox that I prepared? Because there.
You'd like a browser window open?
Yeah. Okay, so this is the demo that I also prepared for you, but we have time to actually show it. This is the slider machine. Let's give it some time to actually load up. There we go. As you can see on the right side there, we have the slider, and we also have the state printed out. So you can see what's going on. And if I hit tab, let me just zoom in, you can see that the focus state is now active, but the previous one was idle. And if we click on the right left, we can see the values change, we can see the event that's happening, etc. But you asked me about styling. So styling in Zag.js happens on top of data attributes. So you can see the JSX that we have here. We can see that we have the root at the root. We can see that we have the label, the output, the control, the track, the range. Every component works on top of component anatomy, and every component has its own part. And in order to style them, first, we already see the opportunity to do inline styles, right? But it could work, but probably not for a whole design system. You can also inspect element, the actual component. Let's see if we can make this work. Okay. Now we can see these data-part attributes. So for every part, there's a data part attributes, and we can use them to build our custom selectors in CSS. And that's what I actually used here in this example. As you can see, we have the thumb. The thumb is that little circle that we interact with. We have the track that is underneath it, and so on. So if I open the CSS file, which is right here, we can see how I actually styled this slider. So I used the data part as the selector here and applied custom CSS. We can also use the hover or the active selectors to actually change anything that we like regarding to the style. But we also have the ability, because we are actually, where were we now? Because we are actually using these parts. These doesn't have necessarily have to be divs. It can be other components from a different component library. But you'll have the behavior already done. So yeah, that is some of the ways that you can style the machines.
Any other questions? Yeah, please.
Yeah, so my question is in two parts actually. One is how well does the library play with things like styled components as a concept? And the other part is about the context-based state management that is based on, does it, I'm guessing it does, but does it instantiate separately each time so that we can load up more instances of the same component in the same view, for example?
Okay, thank you. So the first question was how well it plays with styled components? Or? Yeah, all right, so yeah, well, how styled components work is you write your CSS in JS and it gives you the component, right? So we can do that up top. We can use that styled component right here and then just spread the root props right here, which is what makes Zag.js actually play well with any of the other frameworks. And the second question was
About the state management itself of whether it's instantiated separately each time,
Yeah.
so that we can load up multiple instances of the component.
Yeah, of course. I mean, it does because it's not a singleton, right? We use the machine. We can have this state, and this slider could be reused across the whole app. It has its own local state, and this is actually an example of how we can also extend the context. If you remember previously on the slide, we had we passed the slider.machine, but the slider.machine is actually a function which returns the actual machine. We have the ability here to provide our own context. So if I go here, we can see that we have the context type, slider.context, from the slider machine itself. We can use that type to prepare our props. And if we go to the app, we can see that we have the ability to use those. We have the ability to add our own custom context. So in this case, if we add 50, for example, and hit refresh, now we can see that we start from 50. And the maximum is still 100. So, and we also override the onChange event, which we actually set the value outside in a state variable here. And yeah.
Okay, we had somebody else in the middle wanting to ask something over here.
So my question was about when we start from this non-existing state and we create and go into our loops and everything. So can we also destroy our widget and get back to the unexistent state?
You can use the send method for that. So you can use send unknown to go back, but I think you'll still have the events hooked up because it's React. I guess the unmounting of the component will take care of that because the state of the actual component lives as much as this slider is on the screen, right? It's mounted. So when it down-mounts, it actually cuts down all of the event listeners, and we don't need to care about that.
Okay, so it's completely integrated with the React lifecycle.
Yeah.
Thank you.
Hi. My question is it server-side renderable? I mean, can you render it on the server because it uses refs and stuff?
I think it is, but don't get my word for it. I still haven't tested SSR because we released, I think, 2 weeks ago. So we're still, in the loop of making things work. But I think it is. Yeah.
Cool.
Okay, so Lazar, thank you again. Please give a
Thank
round
you.
of applause for Lazar.